Guess what? It's time again for another edition of VoIP and Tel VUC, the VoIP Users Conference. A lot of people help us out at the VUC to produce these things, and Simwood.com is one of those folks we would like to thank, turning developers into telcos with their leading API, Simwood.com. On the hosted PBX end, we've got OnSIP.com. Those folks, Junction Networks, have been around for a long, long time, and I've been with them for many years, personally, our company, and also the VUC PBX. Don't forget about ZipDX.com. David Frankel's also been a long-time member of the community. He contributes a lot, including the fantastic ZipDX.com conference bridge. You've heard of Voxphone.com, and they are responsible for our local rate dial-ins in something like 48 cities. So if you really must use the telephone system, go for Voxphone. Here's the missing Voxphone slide. Well, I just learned that the cron job is 1 hour off. Ladies and gentlemen, welcome to the VUC. This is the way we roll. Hey, we've got a great crowd this evening. It's evening here, and let me mention in passing that Randall Schwartz is with us, a guest from Floss Weekly. Hey, Randall. And he's muted.
Mute button. There we go. Okay. Hi. There we go. Hi, guys.
A bunch of people from Digium. Dan Lane is here also from Truephone, and we're going to be meeting in Berlin, Dan and a bunch of other people. I'm going to let Matt Jordan from Digium introduce the other folks and the topic, okay? So Matt, you and I met at the last AstroCon. We had a really fun session there, and it was a pleasure to meet you, and I'm glad to have you on the Hangout.
Well, thanks for having us, Randy. It's good to be here. I'm Matt Jordan. I'm the lead on the Asterisk project for Digium. Also on the Hangout, we've got Mark Michelson. Mark, say hello. Unmute yourself. Please.
Hi. How's it going?
So Mark is the technical lead for the Asterisk project and senior software developer here at Digium. We've also got Mr. Joshua Culp, famed wearer of white hats.
Hi, everyone.
Who's also a senior software developer at Digium. And the three of us are going to be talking about Asterisk 12 and what Asterisk 12 is, how we got there, what it means for you, and where we're at today. So I guess I'll take it away. And if anybody at any point in time on Pound VUC or on the phone or anywhere else has any questions, feel free to just ask, jump right in. I'll try not to fall too far off the script here, but you know that I've got sort of on my side here. So Asterisk 12. So the way we do development of Asterisk, we typically get together in October at AstroCon at the conference, and we get in a big room with a whole bunch of other Asterisk developers, and as a community of developers, we plan and talk about what the priorities for the year are going to be. So last year in October, at AstroDevCon, there were about 50 of us, I think, in the room, hashing out what the priorities were for what is going to be Asterisk 12. And the community decided on two large area of topics to focus on. The first is the SIP functionality that is in Asterisk today, and the second is Asterisk APIs, and in particular how Asterisk represents itself to the APIs and how it as it exposes itself to the outside world. In reality, there's two reasons why the community decided to focus on this. The first with the SIP channel driver is that for anybody who's done development of Asterisk, the current SIP channel driver is very difficult to maintain. It's very difficult to extend. ChanSIP, which is the SIP channel driver in Asterisk, is about 35,000 lines of code at this point. And it grew, I'm going to use the word organically, over time, and as time has gone on, it's been more and more difficult to implement new functionality in the channel driver and to do so in a safe manner that doesn't cause regressions for people who are using other devices. The APIs is a whole other kind of problem. With the APIs that we have today, the Asterisk Manager Interface, AMI, and the Asterisk Gateway Interface, AGI, Asterisk tends to expose some of the weirdness that it does internally to the outside world, and that makes it difficult for people to build applications on top of Asterisk. They have to do a lot of bookkeeping, keeping track of what Asterisk has done to their channels, what the state of devices are, and a whole lot of other kinds of things. That makes it really tough for people to build complex telephony applications on Asterisk. So those are sort of the two large areas that we've decided to focus on in Asterisk 12. And as it turns out, both of those areas end up being rather large projects. And we'll kind of go into a little bit why there. But as we start tugging on the various threads of SIP and of APIs, we start pulling apart little fundamental pieces of Asterisk, and that requires us to do some serious architectural reworking within the core of Asterisk. The end result is that Asterisk 12 ends up being unlike any version of Asterisk we've probably released in the last 4 to 5 years. This is a major leap in architecture, in functionality, and in how Asterisk is going to look and behave to everybody who's building things with Asterisk. I think in the end, when you look at what we're doing and where things are going to go and how Asterisk is going to behave, that the risk and the architectural changes are justified, and that it's going to make everybody's life a lot easier for people who are users of Asterisk and the people who are actually building businesses on top of Asterisk, building PBXs and appliances and other kinds of things. So I'm going to kind of talk about those a little bit in reverse order and how we got there. So first of all, before I go jumping off into the various things, we are doing all of this work in public. The community is participating together to do this. All of the project tracking is up on the Asterisk Wiki. If you go to the Asterisk Wiki, wiki.asterisk.org, go down into the development section and look at the Asterisk 12 projects page. There are sub-pages for all of the major tasks. They have all of the issues in the Jira issue tracker. And so we definitely invite everybody who's interested in the project to go take a look at them. And that involves people who want to do development. That involves people who want to test things, who just want to comment on the specifications we've written. So everybody from power users to developers to testers that want to get involved in the project, we definitely invite everybody to go take a look at what's going on. So APIs. So what's up with Asterisk APIs? You know, there's a lot of different ways to express this, but I'd say the first major fundamental problem is just a lack of consistency. And what that means is there's a lack of consistency in what you get over AMI between the various event notifications that it sends out. There's a lack of consistency in terms of tying AMI and AGI together to try to build complex applications. And there's a lack of consistency in trying to maintain the state of what these various things tell you. Probably the most fundamental and obvious problem for anybody who's ever built an application on top of AMI is trying to keep track of what happens to an Asterisk channel. Asterisk channels have a tendency to, at times when you may not always expect it, to be renamed. So you had what you thought was a unique handle to the channel, so sip/foo-01, and now it's sip/foo-034, right? Something happened, and you'll get notified of the rename, but now you have to change and you have to update your state, and you have to go try to figure out, and you have to keep track of all these renames, and it makes trying to keep track of what a channel is in Asterisk very difficult. On top of that, there's a lot of times when you actually want to unify the AMI and the AGI interface. So for people who aren't real familiar with Asterisk, AMI is a call control protocol, while AGI is really a protocol that farms out the actions that you take upon a channel to an external interface, to an external running process. That's fast AGI, which is what most people use. There's a couple various flavors of AGI. And life has left the building. So if I'm going to try to actually unify those two worlds together, where I want to do both call control as well as actions upon a channel, I end up having to take both of those various protocols and tie them together in order to build an application. That ends up being a lot of work and very difficult, plus at the same time the names of channels are changing on you, and so you end up writing huge libraries just to try to actually keep track of what's going on. So that's one major problem that we're going to go tackle, that we've decided to tackle for Asterisk 12, which is essentially if you get handed the handle to a channel, that doesn't change on you. You all can always refer to the channel using the exact same name, and that is good for the lifetime of the path of communication between the device and Asterisk. At the same time, what that means, however, is that we've got to solve a fundamental architectural problem in Asterisk. And really, that goes down to how Asterisk actually bridges two channels together. Asterisk bridging model really is not so much where it doesn't really actually have a bridge object that actually maintains the state of a bridge between the channels. In many ways, two channels are really just happen to be in a state where they're talking together, where they're bridged together. What that means is that it's very difficult for other things to take control of those channels. And so we have an operation that we call a masquerade, where a channel gets swapped out for another channel and another thread takes control of the channel. That's actually what causes a lot of the rename events and other things that happen inside Asterisk. And that makes it very difficult for people to actually keep track of what's going on. So in order to do that, we actually have to go, in order to solve this API consistency problem, we actually have to go tackle the bridging model in Asterisk. To do that, we're actually going to go use the bridging model that we actually put into Asterisk back in 1.6, which we can all thank Mr. Joshua Culp for. The new bridging model in Asterisk is actually already used in Asterisk in certain places. ConfBridge, which was revamped heavily in Asterisk 10, uses the bridge, this exact same bridging model, and it's proven very effective in the past two versions. So we have high confidence that it's a good bridging model to go to move the rest of the Asterisk bridges over to. But there's a huge implications for changing Asterisk architecture to this new bridging model. A lot of things in Asterisk were depending upon the old bridging model, things like CDRs, things like CEL, QLog, AMI, AGI, all kinds of things were depending upon that old bridging model. Well, not as much AGI, but so as we move over to the new bridging model, all those things get affected. The other thing that we're developing in order to provide consistency between interfaces is a new message bus within Asterisk. And that message bus is actually called Stasis Core. That's its name currently today, and probably going to remain the name because it actually makes some sense for that. So what Stasis Core is an internal pub/sub message bus that lets you actually send information about what's going on inside Asterisk to various modules within Asterisk. We actually had already an internal event framework that Russell actually wrote. Thank you, Russell. And that internal event framework lets you actually push device state and MWI and other kinds of information around through Asterisk. And it has been incredibly useful in the past versions of Asterisk to decouple consumers of state to the producers of state. But when we looked at what it was going to take to actually put channel state and bridging state and a whole lot of other large objects on top of there, we kind of needed something a little bit more flexible. At the same time, we're taking the AMI events, which also contain a lot of state information, and putting them out onto Stasis Core. And that requires being able to push arbitrary data across the same message bus model. So we're actually going to be able to push JSON actually as well across this internal message bus. What that lets us do, finally, is to decouple the various interfaces from the things that are producing state. So AMI becomes an interface that's built on top of Stasis Core. There are a lot of other things that also become built on top of Stasis Core. CDRs get built on top of Stasis Core. CEL is going to be built on top of Stasis Core. And that means that now they're just listening for state updates for what's happening inside Asterisk, as opposed to actually having the Asterisk internals specifically have to go do that themselves. In addition, we're going to actually write a new interface that is currently called Stasis HTTP. And so this is sort of a third interface in addition to AMI and AGI, and it's a little bit of a different purpose than what those two interfaces are. The purpose of Stasis HTTP is to let you build your own telephony application. So a good use case for this is, say for example, you wanted to write your own queue application, and you had specific business logic that you wanted to implement in your queue application. Well, today you'd have two options. You could either go into AppQ and hack on that and write your own C code to try to implement your business logic, and maybe it'll work great, but maybe it it'll have some problems because AppQ is another big ball of code that's kind of hard to decipher sometimes. And getting that up back into mainstream suffers from some of the same problems that people trying to push patches in ChanSIP suffer, which is that if you have specific business logic, it doesn't always apply to all consumers of Asterisk. In addition, it's a lot of code, and sometimes the side effects are very strange that happen. So what Stasis HT, the other option you would have instead of hacking on AppQ would be to actually go take AMI and AGI together and try to write your own Q application. And there's a lot of people that actually do this today. People will use combinations of those along with various conference bridges to actually emulate out queues. But again, this is a very complex thing, and you have to write a whole lot of libraries. You have to unify multiple protocols together, and ends up being a whole lot of work in order to achieve what you're trying to do. Stasis HTTP is a different approach. Stasis HTTP, and the purpose of this interface is, say you want to write your own telephony application, and you're going to write your own queue, essentially. And what Stasis HTTP provides is access to the raw telephony primitives and Asterisk through a REST interface with WebSockets for the events that actually tell you what's going on. So when a channel gets put into a Stasis application, a event notification goes out over the WebSocket that says, hey, you have a channel that is in your Stasis application. And it's up to you now to do whatever you want with that channel. You can dial more channels, you can bridge that channel into a bridge, you can play back media on the channel, and the channel is owned completely by you for the lifetime that it's in there. But it's not, the purpose of Stasis HTTP is not to say, well, how do I put this into voicemail now? Well, you would actually have to go back to the dial plan. You would release it back into the dial plan. Or you would write your own Stasis voicemail, right? And it lets you actually do whatever you want to do, controlling those channels and controlling the bridges directly through this REST interface. We're really, really excited about the power that this gives people, because rather than actually relying upon the modules in Asterisk, or rather than having to write your own patches, this lets you build your own telephony applications on top of Asterisk and take advantage of the Asterisk core and its raw primitives through whatever kind of, and apply your own business logic, whatever you want to do to it. So that's sort of kind of the nutshell of the whole API project. We're doing a lot of fundamental re-architecture inside Asterisk to take advantage of the bridging framework. This is going to have large implications on how CDRs look, on how CEL looks. There's going to be changes in these areas. The CDRs are going to behave differently than they do in current versions of Asterisk. What I can say is that we're actually writing everything down this time. We actually are writing specifications for things. There are draft specifications up for some of this stuff. Feedback on that is always welcome. And we're writing specifications for all the interfaces, and we're defining how this stuff is going to work. So although it is going to be a transition going from an older version of Asterisk to Asterisk 12, the transition at least is going to be well documented. So that kind of probably provides some background on the APIs and the bridging and that sort of goal that the Asterisk community set for Asterisk 12. The other goal that the community set, because we're being ambitious this time, is a brand new SIP stack, a whole new SIP channel driver. And when we looked at the current ChanSIP, we actually looked at it and thought, well, maybe can we save it? Can we just re-architect it as is? And numerous people, a lot of people have tried this over the years to try to refactor the existing ChanSIP. And it's been very tough. It's been very difficult to try to do that and actually maintain the existing channel driver at the same time. And so rather than trying to put ourselves through that pain, we instead went with a brand new, oh, hi, David.
Hi.
We're talking about the SIP channel driver right now. So with the SIP channel driver, we decided to write a brand new one. And so we went out to the community, and there was a very long and sometimes passionate discussion about what SIP stack should be chosen, and whether we should write our own SIP stack again, or whether or not we should use a third-party SIP stack. We had a lot of discussion about the design and how all this stuff plugs together. And in the end, the community decided upon PJ SIP, actually, as the SIP stack that we're using for the new SIP channel driver. And a highly modular design. The design that we've kind of focused on lets you plug in SIP functionality into a core framework so that the SIP stack becomes very extendable. Say, for example, you wanted to write your own particular package for a SIP notify request that's specific to a device. You won't actually have to go modify the core pieces of the SIP channel driver in order to do that. You'll be able to write your own resource module that plugs into Asterisk, and it will hook into the framework and be able to provide that functionality. Josh and Mark have been the two guys who have been principally tasked with actually writing the new SIP channel driver. So I'm actually going to hand it over to them a little bit to talk a bit more about that. Josh or Mark, do you guys want to take it away?
Sure, I'll have a go. So let me just say that, first of all, Matt has said a lot of what I would have said about SIP. But as you probably heard him say, we have chosen PJ SIP as our SIP stack that we're building on top of. I figured I'd go a little bit more into the justification behind that. When Josh did some SIP stack research, the big three SIP stacks available in open source we found to be Sophia SIP, Reciprocate, and PJ SIP. And all three have their advantages and their disadvantages. In the end, PJ SIP appeared to be the best choice for us because of it was very fully featured. It has a very active community. It has active maintenance being done on it. And of course, the fact that it's written in C is a big help. And it also didn't really hurt that Josh and I also happen to have a little bit of experience writing code that used PJ SIP ourselves.
So on that note, actually, I'm sorry, Mark, I'll interrupt. So one of the things that, for those of you who were at AstroCon last year, one of the questions that came up was, well, what happened to Asterisk SCF? And although without going into that too much, Asterisk SCF actually used PJ SIP for its SIP stack, and so if for no other reason, we actually had if nothing else happened out of Asterisk SCF, we gained a lot of experience writing the SIP stack on top of PJ SIP. And we've taken that knowledge and we're applying it to Asterisk, and so that has been a huge benefit to this project. So sorry, Mark, I wanted to throw that out there.
That's absolutely fine. So one of the topics that came up on the Asterisk developers mailing list when we mentioned that PJ SIP was going to be our preferred SIP stack was that people are a little bit unhappy with the fact that, at least at the moment anyway, PJ SIP is not available as a package in most packaging systems out there. So for instance, if you were to have a CentOS system and try to do a yum install of, say, a PJ SIP development package, you would not find that. And so we said, okay, well, we'll try to fix that for you. And so Jason Parker here at Digium has actually been doing work and actually has completed the work in order to make PJ SIP available as a loadable module. And for now, we have a Git repo available where you can get the PJ SIP source and install it as a loadable module. And this will eventually be pushed upstream into the PJ SIP project itself. And at that point, then of course, distros can start making their own packages of PJ SIP, and I think everyone will be happy with that result. So that's enough about PJ SIP, I think. So to go into further detail about how this new SIP work differs from the original Chance SIP, probably the biggest thing is actually what Matt touched on, which is that it's a lot more modular than the monolithic Chance SIP was. So, for instance, as Matt said, if you wanted to write something, here's a good example of something. If you wanted to be able to write specific headers on, say, an outgoing invite request or invite response, that sort of thing, all you would have to do is write probably about a 50-line C module in order to do it. You wouldn't have to touch any existing code for SIP anywhere. It would just be a matter of putting it in your own loadable module, and then you can plug it in and everything should just work fine. Similarly, as Matt said, you can hook into the event framework so that if you were to want to receive subscriptions or notifications for specific SIP event packages, it would just work. So
On that same note, Mark, Josh, what was the RFC you wrote that was as an example of how pluggable
it's
the framework is?
Yeah, it's RFC 3326, reason header on SIP responses. So basically, it tells you why in Q931 terms why the call is actually terminated, and that is a completely loadable module and took all of, I think I did it maybe in half an hour to write it. So yeah, really all of this stuff is built as separate modules and builds upon each other to achieve the exact functionality that you need. And really, you can, if you just need, for example, if you don't need a registrar, you don't have to load registrar functionality and potentially expose any of that to the outside world. So it's quite nice.
Another benefit for this architecture too is for people who have traditionally written their own things for their own SIP extensions, their own ways of modifying ChanSIP, and found it difficult to maintain those patches themselves. There is a high likelihood that all that functionality can actually be written as separate modules. So that's got two different implications. One, it's easier to push it upstream because it's much easier for us to verify the correctness of a separate module. And there's very low risk for including separate modules in Asterisk because at the worst that anybody has to do if that module misbehaves is simply disable it. The other benefit is that if you actually don't want to push it upstream, it's much easier to maintain a separate module yourself than it is a sequence of patches, and you're much less likely that things are going to break. So for everybody who actually writes SIP functionality for Asterisk today, this is a much easier architecture to extend and support. And
really it allows us to, as developers, to bring additional functionality to the users quicker. Because ChanSIP itself is a huge mess, and adding functionality is just a nightmare. But since this is so modular, it's easy to add that new functionality and just make it available immediately.
Yeah, so the modularity obviously is a huge plus for this, but there are some other benefits as well. I mean, okay, this is kind of a marginal benefit, but one of the things about PJSIP is it has a lot of features just sort of built into it already, including a couple that Asterisk didn't have yet. So, for instance, it has support for you SIP people out there who are familiar with it. It has reliable provisional responses and prac support. That is something that to give some can't think of the word I'm trying to think of here, but for instance, Ole Johansson, he's a big contributor to Asterisk, a really good member of the SIP community and such, and he spent, I would say, weeks trying to put prac support into ChanSIP in Asterisk because it just meant having to check and double check that everything that you were putting in there is not going to cause any other issues to anywhere else because it's having to touch so many places within just this one giant ball of code. Well, as it turns out, since PJSIP just already has it, it turned out that all we had to do was just, I think, add 2 lines of code or something like that into our new SIP work, and it's all of a sudden enabled and it works perfectly. So that's, a small benefit. But the thing about PJSIP also is that it has the ability, I know a lot of people will really be happy about this, Asterisk only had the ability for you to bind to a single UDP address and a single TCP address, and PJSIP allows you to do a lot more than that. So you can bind to multiple UDP addresses, multiple TCP addresses, and it just works. The other big benefit of our new SIP work is that the threading model is very different. So ChanSIP and Asterisk uses a single thread to read in all incoming requests, and it handles all incoming requests within that single thread. And some people have noticed that if that thread happens to need to take some time, so for instance, if it needs to do, say, a DNS lookup, something like that, then it can cause slowdown in processing of SIP traffic. And one thing we've purposely done this time is to use a thread pool and to not block the thread or threads that are reading SIP traffic in, if at all possible. So as soon as a SIP request or response comes in, it gets farmed out to a thread in a thread pool, and that's where the majority of the work gets done. And the threads also are grouped in such a way that work pertaining to a logical SIP unit, like say a SIP dialog, something like that, will all happen in series. So it means there's a lot less contention, a lot less locking, and we believe that this is going to result in a much more performant SIP experience.
And on that same vein, also one that is much less likely to completely hose up a system if something very off-nominal happens. Today, if a SIP request goes off and hits a database and your database goes down, all SIP requests fail, right? With the new threading model, that SIP request may run into problems, but not every other SIP request that is currently in transit is going to actually be impacted by it. Makes your system a lot more reliable in general as well. And going on the same vein that Mark has been alluding to, there's just all sorts of things that just by implementing this in a more RFC compliant fashion, and probably more in the ways that the RFCs initially intended, has resulted in a lot of new features and benefits that the Asterisk community has been looking for quite a long time. Josh, do you want to kind of go into the registration benefits?
Sure, I'll go down that road. So since I've been part of the Asterisk project, it's been brought up numerous times about how if you register a phone to a SIP peer, that you can only have one contact essentially, so one device registered. And it's been brought up multiple times that that is something people would like to not be true anymore. They'd like to have multiple devices, such as your laptop, your mobile device these days, and your desk phone, all using the same account. And to actually achieve that within Chan SIP would have been possible, but the impact of that would have been quite large. But since this was a completely new SIP stack, and rather SIP channel driver, I implemented that from the beginning. So for Chan Gulp, as we're calling it at the moment, you can actually have, if you configured it to do so, you can have multiple devices registered to a single AOR or account. Like for myself, I have two desk phones here that I use for testing. And I have an account 5201, and both of these are registered to that single 5201. And we've also made available a dial plan function that if you take advantage of this functionality, you can use that to dial both. So if I dial 5201 in my dial plan, they both ring as you'd expect. So that's just one of the things that since we did this from the beginning, we were able to achieve that in a pretty easy fashion. As well, if people do want to go back to the way that Chan SIP did and only allow one device to register, you can also configure things to behave that way. And this is all on a per device basis. So it's not a global setting. Matt, Mark,
I'll talk a little bit. So one of the things that doing this new work has afforded us is we've actually been able to see just, really the majority of the work that has been done has been by Josh and I, with supplemental work by Jason with regards to, excuse me, packaging of PJ Project, and by Kevin Harwell here at Digium for some video support and messaging support, and we've been able to go at a quick tear through this. So we have been, if not on schedule, ahead of schedule for everything that we've been trying to do so far, and that really gives us great hope for when it comes time for people to want to add their own functionality. They won't be having as much difficulty. They should find it a lot easier. And while we haven't been the best at documenting everything so far, we have full plans to, before Asterisk 12 is released, to document absolutely everything that there is, giving tutorials on how to write SIP modules for Asterisk, explaining all configuration options, and everything else you can think of will be on the Asterisk wiki for you to see. So I hope that's a benefit for everyone.
Yeah, and I'd also like to speak a little bit sorcery, which is an internal name or an API name for something I wrote, which is basically the replacement for real time, because real time is interesting and we needed something new for this new SIP work. But sorcery is basically, like I said, a new method of doing real time. You can store information in different mechanisms. For example, if you wanted to store your registrations in a database such as MySQL or Postgres, you can do so. But you can also store other stuff like the configurations for your devices in a file itself. And as well, Sorcery allows you to do caching. So if you don't want to hit your database, you can configure it to cache this information using something like an in-memory cache or memcached, for example, once that's actually written. And this is totally configurable on a deployment basis. So for situations where like you're just running a single system and you just want it to behave like ChanSIP did, you want to configure it from a file, and you want to store your registrations in the local database, that's the way it defaults to. But you can also be as granular as you want, which is quite powerful in the end. And in SQL, you could theoretically store your configuration files in ASCII if you were incredibly cheeky.
One of the things I'm going to kind of allude to with that Sorcery is going to provide us is the ability to really provide an abstraction layer between everything that wants to use persistent storage and the actual persistent storage backends themselves. For those of you who have actually done Asterisk development in the past and you've ever cared about actually persisting something into a dynamic real-time backend, you probably found yourself writing things that looked a lot like SQL queries directly in the module itself. And that ended up making it so that it was very hard to put things into dynamic real-time. What Josh has done with Sorcery is actually provide a real data access layer so that whether or not something is stored in dynamic real-time, the actual modules themselves don't care. They just give the object to Sorcery and say, please store this however the user actually wanted it to be stored. There's a lot of flexibility and power that that's going to actually give us, particularly in the future. And we're not making any commitment to features necessarily that this will allow, but certainly in future versions of Asterisk, that means that creating objects and persisting them in various types of backends and all the directionality kinds of things that you may want to be able to do becomes much more possible. Things like, for example, dynamic creation of endpoints is suddenly a realizable goal as opposed to something that is usually hacked in. So that's a great thing that we've got put into the architecture. So I think that's a pretty good wrap-up of where the SIP channel driver is and where it's going. Kind of just to circle back where the community set out for us and what the goals were for Asterisk 12. And kind of where we're at and where I'm hoping Asterisk 12 is going to be by the time we release the beta. Again, I want to reiterate, these were goals set by the community, and the community is participating in this, and this is a community-driven project. And so where we're at today, we've got 3 major projects that are sort of running in parallel with a lot of dependencies. We've got the SIP project that you'll find up on the Asterisk 12 wiki that Josh and Mark were just talking about. We've got the bridging construction project where we're actually making use of the bridging framework within all the parts of Asterisk. And then we've got our APIs, our Stasis Core and our Stasis HTTP project. And if anybody would like to participate and help us test and help us develop that, we are always looking for participation. And right now, things are probably at that sort of 50% mark. So if you go look at what is Asterisk Trunk today, that has parts of Stasis Core. And then there's other branches out there that are actually listed off those wiki pages for the other kinds of efforts. And things are definitely in a little bit of a state of flux. So if you do want to jump in and help us, that's great. But just keep in mind that you may go try to use some of the things we're talking about, and it's quite in the alpha stage of things. Now, where we're going to be, though, come beta time, and this is something for people who are building systems on top of Asterisk to start planning for, there's going to be a whole new AMI specification. And so although the syntax and some of the semantics of AMI are going to remain the same, there are major differences in AMI and how it conveys state. There's going to be a brand new Stasis HTTP interface for people to go take advantage of to build telephony applications. there's going to be a whole new specification for CDRs, and I know this scares probably everybody. And we did give some thought to just completely removing CDRs from Asterisk, but I think the outcry from everybody would have been deafening. So, but CDRs were so tightly integrated with the old bridging model that there was nothing that could be done other than to essentially rewrite them. But the way they behave is going to be quite different than they have in the past. So people who have built building systems on top of Asterisk are going to need to go take a look at that specification, hopefully provide feedback, and really, look at that as part of their upgrade path. People who have actually gone and made use of CEL, there's going to be changes to the event ordering and how those events are conveyed. And finally, last and certainly not least, there's the whole SIP channel driver. And so you're going to actually have a whole new SIP stack to go work on and go play around with and put in SIP functionality and take advantage of, because really you're looking at a huge performance boost. You're looking at a huge functionality boost that's going to give you. And when you look at all these different efforts coming together in one single version, Asterisk 12 is just a massive, massive release that I think is going to really catapult Asterisk into the next couple of years. I think we're very excited about it. We're very excited about what the community has brought, and it's going to be a lot of fun. So that's sort of my gigantic spiel for this. I've been seeing a couple questions go on Pound VUC as it went by. Does anybody have any questions?
Let's see if we have anybody that's ready to unmute either on the Hangout or on ZipDX. And I see Bob Bowles is speaking there. But anyone else, just unmute yourself, because at this point...
So
go.
I have a question. Well, when you change the interfaces and APIs like that, there's been a lot of projects. Can you hear me? Change the interfaces and APIs like that.
Okay.
Is that me looping?
No,
Somebody else looping?
Yeah, that's John. He muted himself. Go ahead, Randall.
Okay, good. Thanks. So one of the things that I know is that Asterisk is a key component in a lot of other open source software in the world, and I understand the need to move forward and change APIs, but what kind of level of support have you gotten from the community for the people who are bundling Asterisk in with other open source projects?
So far, the support's been pretty good, although I think that I'm actually looking for more feedback. I think it's important that we get the feedback earlier rather than later, which is one of the reasons why we're doing this. But the good thing is actually the timing for doing this major work is actually really good. So Asterisk 11 was an LTS release. And so everybody who's built their applications and their PBXs and everything else on top of Asterisk have an LTS, a long-term support release, to go sit on and support their products for a very long time. You've got multiple years that version is going to be supported. Asterisk 12 is what we call a standard release. It has 1 year of bug fix support, 1 year of security fix support, and then the next version, Asterisk 13, lucky 13, is going to be the next LTS. So there's really a good time frame to take Asterisk 12 and view it as a way to build your product, rebuild your product on top of it to take advantage of all the functionality. And because it's kind of in this staggered LTS/standard release, that gives everybody time before the next LTS comes out to upgrade their products, to work with us, to really help us make sure that we're providing a platform that you want to build on top of.
Awesome, thank you.
Yes, I have a question. A couple of them, actually. What is the time scale for what in this? When will what be? 6 months or something for the betas? Or?
Right. So on the Asterisk wiki, there is a page called Asterisk versions, which is and that actually has the proposed timeline for all releases, including Asterisk 12 and Asterisk 13 and Asterisk 14, and that includes when the betas go out, when the feature freeze reminders go out, and all those other kinds of things. Those dates are always a little tentative. We try not to lock ourselves into a bad decision. So if it comes up at a particular date, and we would have a discussion within the community that, wow, this looks like a really bad idea to release the beta at this time, we won't release the beta until we feel like it's ready to go. But tentatively, so again, I'm emphasizing tentatively here, the beta release will be the third Wednesday in July, with full release tentatively scheduled in October. So that's sort of your Asterisk 12 timeframe. So we've got about another 3 months to go, roughly, in terms of the development before we'd have a beta release out, according to that schedule. Again, all of this is predicated upon things being ready, though, right? We're not going to release something into beta that we haven't actually put through some level of pacing ourselves, that the community hasn't had a chance to absorb. But you know, we're really shooting hard for that third week, Wednesday in July timeframe. That is the goal that we've set.
Did that answer your question, John?
Yeah, that's interesting. I hope they make that. That's very ambitious for all the stuff there.
That, you know, that you almost want to call the subtitle of Asterisk 12 "Go Big or Go Home," right? I mean, we went ambitious on this particular version, and so it's definitely going to be very exciting. If nothing else, the development around here at Digium has been very pedal to the metal, if I can use the phrase. So it's been fun.
It's really necessary because that's the one thing that, although I use Asterisk and you know and so on, all the things you said, you know, you've been reading my mind here because it's all the hardest things to do that you talk about. So that's really good that you're doing that.
Well, that's actually good to hear. It's always good to hear that we're actually addressing the correct things. And, you know, that's one of the great things about actually setting up your project plans with the community. And, you know, this is one of the reasons why I always tell everybody to come to AstroCon if you're a developer or a power user, come to AstroDevCon and get in the room and hash out the ideas with the community, because that's really how we set the goals for the project. And it makes all the difference in the world. And hopefully that means that we're always trying to solve the right things and not solving whatever one or two people thought was a good idea.
Okay, so we're going to again call for questions out there. If anybody has any questions, this is really a good time to take advantage of the fact that Matt and the other guys are here with us, and we're live, but we're going to not be live too much longer. So who's got questions? I see.
G'day, Randy. And
there we go. Chris.
Everybody.
Chris in Sydney.
Yes. 2:47 a.m. So I've got to be, and I'm home, so I've got to be quiet. Just how well does this new SIP stack scale in the Asterisk, or how in the sort of Asterisk environment, and how well do you expect it to be able to scale for concurrent calls, registrations, etc. over 1.8, 10, and 11?
Well, I can say that at this point, we have not done any formal testing of it. However, the threading model that we are using has scalability sort of as the foremost thought, you could say. Scalability as well as reduction of contention, that sort of thing. So, like I said, I can only give estimates, but I would estimate that you are going to see a performance improvement over Asterisk 1.8 or 10 or 11. How much of an improvement? Well, don't know yet. But I imagine that at some point when we get some opportunities, or when someone out in the community gets an opportunity, we could possibly post some numbers up on our wiki that have been experienced, and then we can point to that when people ask that.
I'll speak slightly on the subject. I did some sort of informal, quick testing of, geez, it would have been a month and a half ago, so older code than what we have now, of doing calls per second with short call duration. So basically, worst case, immediate call setup, immediate call teardown. And I won't give numbers because that would be insane, but it did do better than ChanSIP by a noticeable amount.
I'll throw a factor out there that it was more than twice the number. But again, this is preliminary stuff, so we don't really know for sure.
Yeah, that sounds good. Yeah, it was whether it was significant, and twice definitely sounds significant.
There's a couple of questions. One of which is easy to answer and was already answered, I guess, which is to Astricon 2013. The answer being it'll be on the website. But does anybody have any feelings or know anything at all? Is Las Vegas still the main contender? Because I really
No.
personally don't like Las Vegas at all.
No,
it's not.
Adrian here.
Go ahead, Adrian.
Are there any works to support the multi-party conference features that relate to participants' information in Asterisk?
We're not. Go ahead, Josh. You can answer that.
Okay, I'm not sure if I want to now, but okay. I wouldn't say personally it's on my system. It's on my list of stuff I'd like to take a look at, and I've made sure that the design, it shouldn't forbid it from ever being implemented. But I can't say when or how or.
Is it like when I heard the term modular before? Is it possible by the new design to add like event packages to subscribe, notify to stuff that developers might think useful in the future? Can this be easily added?
Yeah. No, the design, yeah, you can do that easily. That's why it shouldn't. It'll eventually happen, I'm sure. So yeah.
There is one nice thing that kind of on that same vein, Adrian. So let's say you actually had a multi-party conference going on in Asterisk. Right now, getting that information from the existing SIP channel driver would be really difficult to do. This is one of the really cool things about the various architectures that are all kind of coming together to build modules. So on top of Stasis Core, you can, in a SIP resource module, subscribe for bridge notifications. So you can actually know that you have multiple SIP channels that have entered into a multi-party conference. And then in that SIP resource module, do whatever you want. Send out event notification packages and all sorts of other things. So without actually having to go into the actual bridging core and try to hack something inside of there. So all these kinds of the bridge architecture, the Stasis Core message bus, the modular SIP stack, all sort of kind of comes together to let people be able to extend Asterisk in a much more easy fashion. Now, whether or not we actually get...
Asterisk has multi-channel feature, which is great and tries to unify everything. But I think when you look at interoperability beyond Asterisk, I mean, imagine you build another client, or you want to cascade information from one system to another. Conferencing related, there is one RFC that got some traction beyond a single protocol right now. For distributing this participants' information, which is a request for comments from the ITF that describes the payload for this information. And right now there are solutions in both SIP and XMPP world using that model. So my question is really focused on, are you planning to support conference info event package as per that specification, or do you have some other model that you want to advertise?
I'm not sure I've got an answer for that just yet. I don't think, I would say that what we're building right now is an architecture that can support it. I don't think we're going to be able to commit to doing that for Asterisk 12. Simply because we've got 3 months left to go. But at the same time, there's no reason that we wouldn't be able to support that particular event package.
It's I think 4575. I'm talking strictly about RFC 4575, which is right now supported by 2 clients, which is Jitsi and Blink in the open source domain, and other servers support it. And I'm wondering if Asterisk pursues this, or sees this just as some irrelevant thing, or is it relevant? Or
well, I'm certain it's relevant. There's no question about that. It's just more or less whether or not we can fit it into the current development time frame for 12. Josh, are you a little bit more familiar with that particular RFC?
I am, but I won't commit to having it for Asterisk 12.
Yeah, I think that's probably where we're at right now, Adrian, that it's not, it is certainly something that we would love to go do, but we're really focused right now on just getting the basic functionality built up in the SIP channel driver and making sure that we've got an architecture in Asterisk that allows us to support those kinds of RFCs. Because right now, I mean, if we actually chose to go do that in the existing architecture, it'd be incredibly challenging and highly prone to breaking the world. And that's the kind of thing that we're trying to prevent.
Okay, fair enough.
Thanks, Adrian. That was funny because that was like called in and then there was a boom. Oh, mute, I guess. Who else has questions? We have to take advantage of this opportunity, folks. And there's a whole bunch of people watching, by the way, who can't ask questions unless they're in IRC.
I'm surprised I haven't gotten anything about CDRs yet. Usually that engenders lots of passion in people. So
there was a lot of chatter too right before because somebody was asking about billing and so on. So have you got anything to mention about CDR? Or does anybody have any questions about CDR? We were talking about something. You know what? Saul just said, any estimations on when Chan Gulp will make it to trunk? So there's a specific and concrete question for you.
Soon.
Yeah, I would say soon. Specifically, I actually asked Matt that question this morning about when would be a good time to merge the SIP work we've been doing into Asterisk Trunk. And I believe that once I finish up with the pub sub-architecture, in other words, the SIP subscribe and notify support and getting message waiting indication working properly, then we'll go ahead and merge that into Trunk, and it'll be there. And so as far as the time frame for that is concerned, it should be sometime within the next 2 weeks, but I would expect probably more like by the end of this week.
Oh, so to answer Paul's question, by the way, Julie just let me know I can publicly say this. So AstraCon 2013 is going to be in Atlanta again. We liked it so much, we're going to do it there again. And it'll be early October. I don't have a concrete date yet, but early October.
So we have a VUC scoop that AstraCon 2013 is going to be in Atlanta. Excellent. That's great news. Yeah, well, that's closer to me, too, so that's nice.
I want to know what Russell's CDR question is.
Okay, it's nothing to be afraid of. Actually, I was just kind of curious a bit about the what it'll look like. So the previous CDRs, there were sort of two models, right? There's CDR and CEL. The CDRs were an attempt to mash up what happened in a call into a single record, and then you had CEL, which was a list of events of everything that happened. So I guess my question is, what's the plan for the next version? Is it still sort of these two approaches, or something different, or only one of them, or what's it look like?
Still two approaches. CEL actually is going to be probably the least changed, right? Because it's still going to be events. It's just when the events happen change because you've got a different bridging framework. CDRs, there's a couple fundamental assumptions that CDRs made that I think are impossible to actually fulfill, which is exactly what you just said, which is that you can actually have a single record that tells you everything about whatever your concept of a call is. Mm-hmm. And, that's insane. Really what the model that we're going to is that each record in a CDR tells you about the path of communication between two endpoints. And it is a record of how long that path of communication existed. And it could be between two endpoints or between an endpoint and asterisk. So if you have, for example, a blind transfer, you don't have just one CDR record. You have at least two, right? One between party A and party B, and one between party B and wherever it went off to when it got blind transferred away. You have an attended transfer. You're going to have at least three CDR records, one for A and B, one for the consultation period between A and C, and one for between B and C when the attended transfer was completed. Now, whether or not you bill for all of those, that's a question for a billing system. And Asterisk is not a billing system. Asterisk should not be in the business of trying to be a billing system, but it should provide you enough information that you can go compute whatever billing things you want to go bill for and say, well, I don't bill for the consultation period, but I'm definitely going to bill for both legs of those attended transfer periods. And so you actually have those things to go charge for. But yeah, the assumption that we could do all of this in a single record was, in my opinion, fundamentally flawed. And so we're not going to try to do that.
Sure, yeah. Yeah, it was that assumption and then or we'll use the term organic again, organically modified from there to sort of try to account for things and to the point where it didn't really make much sense. So cool, thanks a lot.
Yeah, and one thing I'll say is that with the old bridging model, trying to do the fix-up stuff in the masquerades made it really hard to try to manage the state of all this stuff. The bridging model makes it a lot easier, and that actually there's two implications of that. One is that hopefully we'll actually be able to give you the correct information now when transfers and other kinds of things happen. And also, and this is something I didn't actually mention, we actually have now the ability to do true two-party to multi-party transitions without actually doing anything crazy through AMI. So you can be in a two-party bridge, do an attended transfer, and Richard Mudgett actually just sort of hacked this in there as a test. Rather than completing the attended transfer, you can actually hit *3 and it'll actually pull all the participants into a multi-party bridge. So we actually, because we've got those kinds of things, you actually need to be able to account for what happens when you have multiple paths of communication within a single bridge. And the bridging framework makes that actually possible to track and keep accounting for, and it's not even a lot of code to do it. So CDRs, but that also means that a lot of the old CDR functions like fork CDR are going to exist but be dramatically pared down because there's not as much need for them, and a lot of the things that they were trying to do just don't make sense anymore in the new framework.
Cool. Yeah, all this stuff sounds really awesome. The CDR stuff and everything you guys have talked about, it's really exciting. It's a nice work.
Thank you.
Since we don't have Carl with us, apparently, Carl will interrupt if he's there, but we do have James Bodie, and James has a question.
Yeah, it's good to see Josh here. So Josh, every time I see you, I ask you for a quick update on the Asterisk WebRTC status. It's always interesting. So what's the picture today, Josh?
Yes.
Sorry.
No, there's been no recent work on that since all of our effort currently is towards all the Asterisk 12 stuff, and WebRTC is still undergoing development.
It's worth noting, though, that Jason Parker has been at work on and is completing having WebSocket support for the new SIP work that we're doing. So that will be present if you switch over to using the new SIP work from the old. You'll still have SIP over WebSockets.
Okay, it's still early days yet, so you've got a bit of time to get it all sorted out, I guess.
You know, there's a lot of, we're watching the IETF just like everybody else, and there's a lot of sausage still being made. And, you know, take, of course, the good old VP8 versus H.264 debate, right? We could go implement pass-through support for VP8 and go spend the time doing that. And there's a very good chance that Digium will do that, or somebody else in the community will do that, because that's certainly something that would be great to have in Asterisk. But it's still a debate being held in the IETF. So do you go spend developer resources writing pass-through support for a codec that we're not really sure is actually going to be used by WebRTC yet? So we're still watching everything, and we're still paying very close attention. And you know, WebRTC is going to be, in my opinion anyway, still a fundamental revolution to unified communications. It's something that Asterisk is going to be playing a very major role in, and it's something that we're very concerned about and watching. But, you know, 12, there's so many architectural things that we're trying to bite off in this release that I think if we went and say if we went out and wrote a Chan rope, right, that'd be great. But it's not going to necessarily benefit everybody quite as much if we just got our SIP functionality nailed down at this point in time.
Hey, Matt, don't get me wrong. I think what you've actually achieved in the last 12 months is absolutely outstanding. And the list of things that you're undertaking, I think is absolutely spot on. And so I think I'd probably be very worried if you were trying to do trying to drop in a half-baked WebRTC implementation as well. It would just be too much. Can I thank you, Matt, for what you've done? I mean, when Kevin exited stage right, everybody went, gulp, what's going to happen now? But I have to say you've done an absolutely wonderful job at hanging everything together and getting things moving again. So from where I'm sitting, thank you very much, Matt, for that, and the team.
Yeah, well, thank you, and again, actually, really, it's I appreciate that, but it's a team effort, right? You know, there's a reason why Mark and Josh are on here, and there's a whole team of people here at Digium that support it, and there's a whole community supporting the project. You know, I mean, it's been real exciting to see, you know, Walter Dokes and Michael Young and Sean Bright and Ule and all these people doing all sorts of great contributions to the project. In fact, actually, you know, calling out two people right there, Michael Young and Walter Dokes. If you go take a look at the issue tracker, those guys are solving all sorts of bugs in the existing stuff. And you know, Michael Young is one of the guys who worked on the SIP security event framework back in Asterisk 10. So, you know, Michael, if you're hanging out in Pond VUC and you want to write the SIP security event framework for the new SIP channel driver, that'd be great. But, you know, there's a lot of really awesome people in the community who make this stuff possible. And it's the reason why Asterisk is what it is today. So definitely a large multi-team effort.
Brilliant.
I want to echo James's comment. Thank you very much, Matt. You're doing a great job. I agree. We were all very impressed as my microphone falls. We were all very impressed at Asterisk with the meeting that we had, the meetings, plural, that we had with you. And I want to send my appreciation to everybody, Mark and Josh. You guys, fantastic. We were really happy to have you with us. Thank you very much for coming by and sharing.
Thank you, Randy. We really appreciate you having us, and you know, maybe we'll do this again in a couple months when we're getting closer to that beta time frame, because I think it'll be really fun to see where everything ends up.
As you may know, this used to be called, started life as the Asterisk Users Conference in 2007. So you are always welcome here. With that, we're going to go ahead and cue the music and roll the credits. This concludes our test. Had it been an actual alert, you would have been instructed to go to VUC.me. If you happen to be in Europe, please don't miss the chance to come and meet up with the VUC in Berlin. We'll be converging on Kamailio World, which is April 15th through 17th in Berlin, and you can get more information on that at conference.kamailio.com. Check that out, please, and don't miss a chance to taste some wine with us.